So now in this video we're going to look at the OR logic gate, and one way you can make it is with a couple mechanical switches. And so our load, which we're going to attach to the output, is going to be an LED. And of course, remember, the LED, the long lead, the anode, needs to go towards the more positive side, the short lead, the cathode, towards the more negative side for it to light up. But we have it there. So what we can do, I have this jumper here that goes a couple spots away from that one. We can take a push button switch, and these are really nice here, and put that on there. We can turn the load on in this case, put the output high, however you want to talk about it. But we can also take this jumper here, which is a couple spots above that one. These switches, they go across the board. They're separated top to bottom, and so I'll plug that in. So the top of this switch is connected to the yellow jumper that goes to the positive rail, and the bottom of the switch goes over there. If I push the button, now you can see the LED turns on. So that is the rule for the OR gate. That input goes high, the output goes high, or that input goes high and the output goes high. And you can also do both. That is the other way. So there is a truth table with the logic gates, and this is what the OR gate looks like. So 0 is off. We're not getting a high signal. If you don't press either of them, in this case, the output is low, the LED is off. You press 1, the LED is on, you get a high signal, you get positive coming to the switch, and now you got positive across the LED, the output. Or the other one there, same thing, turns on, or you can press both, they turn on. So that is the rule for the OR gate. So now there's a couple other ways we're going to look at the OR gate, and the next one is going to be the transistor version. So we're going to use NPN bipolar junction transistors, and we're going to have to zoom back a little bit, and I spread it out on the board a bit to make it easier to see. And but in any case, this is something similar to how people normally draw it in schematic form. And since we have a crossover and a spot where we kind of have 4 areas, I put dots on this schematic. So that bugs some people when you have a busy intersection like this and there's no dot where they all connect. So there's no connection there. That is jumping over there. I don't always put the dot there, but I'm going to try to do it more when you have a bunch of stuff connecting all at one point. So in any case, the principle is the same. We have the positive side of the power supply, which is actually going to go to the I'm going to swap where the resistors and the switches are, unfortunately. And then also we're going to go to the collector of 2 transistors. And so we're basically wiring the transistors in parallel. That is the main thing. So I have a switch right there, and a switch, or a resistor, 10 kilo ohm resistor, and a 10 kilo ohm resistor right there that we're going to attach the switch to. So as I said before, we swapped where the resistor and the switch is going to go. So the switch will be here. The other side of the switch is going to go to the base of the 2 transistors. So we will do that now, and I will pluck them from there. And so it's going to be the resistor to the base, the middle pin. So I can just connect to the resistor, and I know it's kind of hard to see, so I will pop this out, and you can see the bottom part of the switch there. It's separated top to bottom, is 1 pin below the switch, and it also comes to this jumper. That is, I have that off on spot. There we go. Now it's to the resistor. And so the collector is going to go to the positive rail. This is the 2N3904. The pin layout is emitter to the left, base in the middle, and collector to the right. So the collector is going to go to the jumper and the switch to the base. And now you can see we got this jumper which comes over to the emitter of that transistor. So the two emitters are connected, and in a sense the two collectors are connected because these two positive rails are connected, and their bases have a resistor though and a switch in between them that are separate. So we have to get this switch also, so I will pop it there, and that's going to go to the base. I can pluck this out right now. So this jumper that goes to the positive rail is to the middle of the switch there, and we'll put the base to the switch. The emitter is to that jumper that goes to the other emitter, and the collector is going to the positive rail, which goes to the positive rail there. So basically the transistors are in parallel for the most part, and remember the switch and the resistor are swapped right there. So I know that's a bit confusing, but hopefully you still picked all that up. Now we're gonna take a 4.7 kilo ohm resistor and put it to ground right there. So these are really wired kind of as an emitter follower, a double emitter follower. So it's going to transfer the voltage that we give to the base, minus 0.6 volts probably, to the LED, and a 1 kilo ohm resistor. So I'm using 1 kilo ohm resistors to protect the LEDs in all these circuits. So we can go up a bit in voltage, but the integrated circuit that we're working with is really only intended for up to 6 volts. But in any case, we're back to the same situation, unless I miswired something, but I don't think I did. There we go. We can hit that switch, the LED turns on, or that switch and the LED turns on, or both of them right there. So now the next circuit is an integrated circuit. It's a quad 2-input OR gate. So we're looking at the one on the board here. It's an MM74HC32N, and I also have an LS version. It starts with SN. So I think this one is made by ON Semiconductor. I could be wrong. And that one I think is made by Texas Instrument. And I think that's what the first two letters are. But in any case, this one has quite a bit different properties, but the pin layout is the same. There's also an integrated circuit like this that is a 4000 series, and from what I remember, the pin layout, the top two are like this, but then the bottom two, the output, Y stands for output, and I don't know why, I never really looked up the detail in that, but the output is on top for the 4000 series. But in any case, this one especially is pretty straightforward. We cannot leave the pins floating. We either have to give it a, we're using this OR gate right here. We're ignoring the other three. So you can use 1, 2, 3, or 4 of them, whichever ones you want. So the output, again, I have an LED and a 1 kilo ohm resistor. Again, order does not matter. They are in series, but the long lead, the anode, has to go to the output. We actually don't have to do that. We can put the resistor to the positive rail and turn the LED around. The output is low, and so the LED will turn on. But we're going to stick with the more conventional, waiting for the output to go high so that the LED turns on. So we go there. Now, when I pull one of these jumpers, they're both going to the two inputs up there. I'll make a little more room there. You can see the LED at the bottom pin, that red jumper, second pin up. That's actually pin 8, pin 9, and then pin 10. And then we got the blue one on pin 10. Third one up So when I pull this, you're going to actually see the LED turn on. That's because we don't have a solid low signal. And you'll see it get a little bit brighter when we touch the positive rail. So now we got one of them given a high signal. Either one is given a high signal. Now the other one, the other input's given a high signal. We got a high output. Again, when we're floating, we're in a state where the pin is getting a false signal. This is like an antenna, basically, giving it a false signal. But in case they're both off, we can set them both high. They were both low. Now we can set them both high. The output is high. So the integrated circuit does everything for you. You just have to give it the signals and decide what load you want. And this particular integrated circuit, I think, can power quite a bit. I believe it's 25 milliamps to sink and source, whereas the other two versions, I think you are far more limited on what you can do. This one, I think all you can do is source the current for the most part. But in any case, and that one, I think you have to have 5 volts. This one, according to the data sheet, the recommended range, I believe the maximum voltage is 7 volts, I believe, but the recommended range is from 2 volts. And you can see the LED is still kind of lit. It is a 1 kilo ohm resistor, and so we can put another one in parallel, and there you can see it got a bit brighter. So it's just that high value resistor. Now I just put it up to 3 volts, 4, 5, 6, and we're doing good right now. Now again, we're floating. I'll go to the negative rail, floating, go to the negative rail, and we have 2 low inputs, and so the output is low. But if one or the other goes high, then the output goes high. So that's really about all there is to the OR gate. So I haven't made a circuit yet where I really needed an OR gate. I've only done demonstration circuits for them, but it's not too complicated. So hopefully I'll have something interesting for them later on. Actually, a battery backup. You could have one power supply powering it, and if you can choose between 2 or something, maybe something will work if one power supply is available or the other, then maybe you would have an OR gate like that. That might be something I'll end up somewhere in the future, but for now, this is it. So hope you enjoyed. Thanks for watching. I will see you in the next video.